Applications of electrostatics. We've been studying electrostatics. It deals with the electric force, field, potential energy, and voltage. Here, remember, we have electric field, then electric force, electric potential energy, and voltage. Of stationary charges, nobody's moving here. Moving charges will be covered in the electric current and circuits unit. Charges can build up on a surface due to contact. Rubbing a glass rod with silk will separate the positive and negative charges, so the rod acquires a positive charge and the silk negative. The rod will then be attracted to the silk by Coulomb's law. A common name for electrostatics is static electricity. In addition to physics demonstrations, the electrostatic attraction has many practical applications, but it can also cause damage if not properly accounted for. Photocopy machines. They spray ink on a page to copy an original document. Plastic wrap as it adheres itself to keep food fresh. Spray painting cars in automobile repair shops. Electrostatic precipitators that remove harmful particles from the air. A Van de Graaff generator or accelerator. You can do nuclear physics with that if it's powerful enough. And then, alternate paths must be provided for electrical discharge for sensitive electronic equipment, your phone for instance, or they'll be damaged. And then helicopters generate tremendous amounts of static electricity as their blades work through the air, and you have to discharge it before they land. Most of these times, these effects are either not very noticeable or very dramatic, but if a significant amount of charge builds up on a surface or in an area of space, it will generate a large electric field, right? Electric field is KQ over R squared, so a big Q, big field. That can then have a large electric potential difference between areas. If the field and potential difference get large enough, the built-up charges will move again, very rapidly, until the potential difference is zero. This happens on a small scale. When you shuffle your shoes on a carpet in the winter and then touch a doorknob, you see a small blue light streak between your fingers and the doorknob, and you feel a shock. It doesn't feel very good. Does this remind you of something larger? Lightning. More about lightning. During a storm, water, ice, and snow particles in the clouds collide with each other, and they cause a separation of charge, just like in the glass rod, for example, typically resulting in the negative charges arranging themselves at the bottom of the clouds. This then induces a positive charge on the ground, just like when we had that charged plastic ruler inducing a charge on bits of paper. A very strong electric field and electric potential difference between the ground and the clouds is created. And when it gets large enough, there's a massive amount of negative charge moving from the cloud to the ground, a lightning bolt. We call this electrostatics because the time the charges are moving is very, very short. Okay, you could say once they start moving then you have electric current, but the whole buildup is due to electrostatics. Stronger electric fields are created around pointed objects. This enabled Ben Franklin to invent lightning rods to protect buildings. The rods are pointed and are connected with a wire to the ground. Lightning will flow to areas of strong electric fields, so the rod will protect the building by providing a path for the charge from the clouds to the ground, and not through your house. Here's a great website where you can find more interesting and exciting facts about lightning.